Hello everyone. Welcome to switispeaksOfficial YouTube channel. This is Sweetie Pinjani. We are in UVM Basic series. Today we are going to cover a topic UVM phases. In case you have not gone through the previous lectures in this series, I request you to please go through them first. This is a continuation of that. Let's talk about UVM phases now. In UVM, you have the test bench components. We had discussed in detail about each component in UVM test bench. There is a lecture on UVM TP component and there is also a lecture on UVM test bench architecture. In case you have not gone through, please go through those lectures. It's in the same series. Each of this test bench component in your UVM is derived from UVM component. UVM component is an inbuilt class inside your UVM using which you derive each of your UVM component. And this each TB component which is derived from your UVM component is going to contain your predefined phases. There are going to be some predefined phases in each of your test bench component. And these phases are going to be implemented as callback methods. Each of your TB component is derived from UVM component and each of this component, say for example driver will have some predefined phases, monitor will have some predefined phases, and these phases are represented as callback methods. One thing to remember is these phases are executed in sequence. Until you finish one phase, you can't move to next phase. We have a build phase. Until the build phase is not complete, we will not move to run phase. Until run is not done, we will not move to cleanup. It's in sequence. Because it's in sequence, it helps in synchronizing of your test bench environment. How? I told you that each component has predefined phases. Each component is going to have build phase. Until your build phase for each component is not complete, we will not have run phase. Run phase is not there in each component, it is there in some components. But until all your build phases are completed, we will not do the run. It means you are ensuring, even though the components are different, your entire test bench environment, whatever components they have, are in sync. Until build is not completed, we will never move to run. And until run of all the components is not completed, we are not going to do cleanup. This is how the synchronization happens because you cannot move to next phase until the current phase is completed. Another point to notice, there are some phases which will consume time. For example, run. Run is going to consume time. The phases which consume time will be implemented as task. Phases which do not consume time are going to be implemented as function. There are three major categories of phases. First is the build phase. It is used to build and construct the test bench. The name itself says build. It means we are building something. What will we build in UVM? We will build test bench. We will construct and we will configure it also. Example can be building any of your test bench components, say monitor or driver. Then after that we need to run. So we will have the runtime phases. As I said, runtime phases are going to be time consuming. One phase inside the runtime phase is run. It is going to consume time. That is why it will be implemented as task. Example is when you run your test, when you run your simulation, it will have some delays, it will have some transaction. All that will happen in the runtime phases. Then we have cleanup phases. You have done build, you have done run. Now whatever run has happened, I need the results for that. I need the report. I need to collect and report the results. The results can be pass or fail. Your test is passing or failing. The results can be in the form of coverage. What is your coverage? All that will happen in the cleanup phase. Let us understand this with the help of diagram, because with the help of diagram it's very easy to understand. First thing which we saw is every test bench component is going to be derived from your UVM component. All your UVM test bench components are derived from your UVM component. And these UVM test bench components. Each of these UVM test bench components are going to have some predefined phases. And these phases were represented in the form of callback methods. We had three major categories of phases: build, run, and cleanup. Each of these phases are going to have subphases. Build is going to have some subphases, run is going to have some subphases. Similarly, cleanup will have some subphases. One thing to remember is until all the phases inside your build are not completed, you can't move to run. Here you can see arrow. It means first we will do all this, then we will go to run. After coming to run, we will do all this, then we will go to cleanup. In build, there will be three phases which will be build, connect, end of elab. We are going to learn in detail about each of this. For now, just remember build will have three, which is build, connect, end of elab. Run is going to have start of sim. Then it will have run also. A run is going to have start of sim. There is also a run, and then it will have reset, configure, main, shutdown. Then cleanup is going to have extract, check, report, and find. First build will happen, then everything inside run will happen, then cleanup will happen. Now, depending on whether it consumes time or not, if any of the phase is consuming time, it is implemented as task. For example, run. Inside this run, there is also a phase which is named as run. These are there, except that there is also a phase which itself is named as run. That is a task because it consumes time. If it doesn't consume time, then we implement it as function. Simple diagram to understand. Each of the UVM test bench component is going to extend your UVM component. Each UVM test bench component has some predefined phases which are implemented in the form of callback methods. There are three major categories of phases: build, run, and cleanup. Until you don't finish one phase, we can't move to next. And each of these three phases has the subphase. Depending on whether your phase is consuming time or not, if it is consuming time, we implement it as task. If it doesn't consume time, we implement it as function. Now let's move further. We will see each phase in detail. Build phase. If you remember, I told build. The name itself says we are building something. What will we build in UVM? We will build the UVM test bench. Build and configure. Here you can remember it in the form of three C's. We do build, which is construct. C, three C's. Construct, configure, connect. Construct, configure, connect. Remember it like this, three C's. This is what happens in the build phase. Build phase is the phase which is the first phase in your UVM test bench simulation. It is executed at the start, very first phase. You need to build the components first before doing anything. It doesn't consume time. That's why all these are implemented as functions. The build phases can be built. In the build, we will construct the test bench hierarchy from top to bottom. Remember, first top will get constructed, then bottom. Whatever will be top, first that, then bottom. And then we construct these components using UVM Factory. We learnt about UVM Factory. There is a complete tutorial on UVM Factory which is uploaded in switispeaksOfficial YouTube channel by Sweetie Pinjani. In this series itself, which is UVM Basics, you can go through that video lecture. It will tell you how we register the components with the factory. In order to construct the components, it's important to register them with the factory, which we do in the build phase. Then in the build, we do connect. Build has happened. Now the components need to interact with each other. How will they get interacted with each other? By connecting them. We call them as TLM connections. We establish these connections between the components, and we also assign some handles to test bench resources. What are these resources? We are going to learn in detail. Don't worry about this. Even how to make these connections, we are going to learn about it in the upcoming lectures. For now, just remember, in the connect phase, we need to establish the connections between your component, and we need to assign handles to your test bench resources. This connect phase is bottom up. Build was top to bottom. Connect is bottom up or bottom top. Then we have end of elaboration. In end of elaboration, if you want to modify some structure, config, or connectivity of the test bench before starting the simulation, you can do that. Because after end of elaboration, we need to start simulation. Before that, if you want to change something, change it. After that, simulation will start. Simple. What we do in build, remember 3 C's: construct, configure, connect. Construct is the first thing, connect is the second thing, and configure is the third thing if you want to configure something. What are the run phases? Run phases main purpose is to generate and run your test bench stimulus. Here in the run phase, remember we will have start of simulation first. First the simulation will start, then the run will be called, and with this run itself, in parallel we are going to run some more phases. I'll tell you what are those phases, but remember first will be start of simulation, then will be run, but along with run some more phases are there in parallel. We will see about that now. And another important thing is whatever phases are going to run in parallel, these are the phases: reset, configure, main, and shutdown. Four main phases which will run in parallel with the run: reset, configure, main, and shutdown. And they can also have pre and post. If you want to do something before doing reset, if you want to do something after doing reset, if you want to do something before doing configure, want to do something after doing configure, so like this we have pre and post also in each. But mostly pre and post are not used. Most of the times we are going to use just reset, configure, main, shutdown. UVM does have a provision for pre and post in case, in very rare cases this is used. Mainly we will just use this. That's why we will focus on this. Reset, configure, main, shutdown. For your information, I'm letting you know each of this will also have pre and post variants, like pre reset, post reset, pre configure, post configure, pre main, post main, pre shutdown, post shutdown, and so on. Now let's understand what are these run phases. First was start of simulation. Since it doesn't consume any time, it is a function. What it does is it will display the topology or config information. The simulation is starting, right? So we need the basic information: what is the configuration, what is the topology of your test bench. Those kind of things will happen at the start of your simulation. Then in the run consumes time. That's why it's implemented as a task. What it will do, it will do the actual stimulus generation for you and checking. What you will give some stimulus to the design and you will check some outputs. All these things happen in your run phases. It is used in the run phase. Mostly your transactions will happen. So whatever components are related to transaction, like drivers and monitors, we had discussed the functionality of these components in the UVM test bench components tutorial, which is there in the same series. There you will know that driver and monitors are the transactors. Such transactors are going to have the run phase. Then I told you there are certain phases which will run in parallel with your run phase. First start of simulation will happen. When that completes, run, and along with run, these things are going to run in parallel. But in order, like these four are in parallel with the run, but first reset will happen, then configure, then main, then shutdown. However, all these four are in parallel with run. Run is executing, along with that the sequence will execute. Reset, configure, main, shutdown, the sequence, and run. These two are in parallel. And such runtime phases are only implemented in test and environment. Only these two components in UVM will have your runtime phases. Only inside test and environment you are going to see. What are these four phases? Let's understand. First was reset. Reset is to do some reset type of operation. It is reserved for your DUT, which is design under test or interface reset behavior. Anything related to reset. One example can be if you want to generate reset and put interface to your default state. After reset, everything should come in default state. That can be a part of your reset phase. After reset, we have to configure. Example can be you have memories in your DUT, you want to configure them. Program the DUT, whatever basic configuration you want to have, and then program the memories. Example, you want to be in a ready state for your test to start. So you will make the ready signal as 1. This can be one example of what we do in the configure phase. Then we have main. In main, whatever stimulus is there inside your test case is generated and it is applied to your DUT. And then this particular main phase will complete only when your stimulation is completed or you have certain timeout. You have set a timeout and that time has elapsed. That time or when your stimulation has completed. In these two scenarios, your main will be exited. Then we have shutdown. Entire stimulus is propagated to DUT. Your stimulus has completed, it is propagated to DUT. If there is any resultant data which you want to drain away, that you will drain away in the shutdown. And if there are some time consuming sequence, like everything is done, design stimulus are applied. Now, if you want to read certain status registers, that you can do in the shutdown. Quickly, let's revise. Run phases. First will be start of simulation, where your simulation will start. You will display the test bench topology configuration. Then you will have run and the parallel runtime phases which execute in parallel. Run will do your stimulus generation. Run is only used by transactors like drivers and monitors. Along with run, there are parallel runtime phases which execute in parallel to run, but these four execute in sequence. With run, your reset will start, and after reset is completed, configure will happen, then main, then shutdown, and all this four sequence is running in parallel with your run. What happens in reset? It is for the reset behavior. In configure, we will configure the DUT. In main, you will actually generate the stimulus word DUT, and in shutdown, we will do some time consuming sequence, like if I want to read the register status. Now, what are cleanup phases? Your build is done, your run is done. Now we need to clean up. Cleanup is used to determine the status of your test, whether it was pass or fail. In cleanup, I can also analyze the coverage. These are some things which we do. Because you want to analyze the coverage or you want to check the pass fail status, pass fail status comes from scoreboard. We are going to see about the scoreboard component in detail in upcoming lectures. For now, just remember that pass fail status will come from scoreboard. That is why you need to extract some information from scoreboard. You also need to analyze your coverage goal. That can happen in your coverage monitors, functional coverage monitors. That's why in the cleanup phase, you need information from scoreboard and functional coverage monitors. Since the cleanup phases don't consume time, they will be implemented as functions. Another thing to remember is they are implemented in bottom top approach. All the cleanup phases are in bottom top. Let's see what are the cleanup phases. The first cleanup phase is extract. It will retrieve and process information from your scoreboard and functional coverage monitors. Because our goal in cleanup is to know the status, whether it is pass or fail, and analyze coverage goal. For that, we need to retrieve the information, which is the extract. Extract itself says that I am extracting something. What I am extracting? Information which I need. What information I need in the cleanup phase, whether pass or fail has happened, or what are the coverage. From where I will get? From scoreboard and functional coverage monitors. This extract phase is used by some analysis components wherever the analysis is happening. For example, in scoreboard, we are analyzing whether the test is pass or fail. In functional coverage monitors, we analyze the coverage. These are the analysis components where some kind of analysis is happening. Then we have check. For example, whether the DUT has behaved correctly. If the DUT has behaved correctly, then it is pass. If it has not behaved correctly, it is fail. So after extracting the information, I need to check. Check happens in the check phase, whether DUT behaved correctly, whether there were some errors. And again, this is used by analysis component. Then we have report. You have extracted, you have checked. Now you know what has happened. You can display the results. Or if you want, you can write the results to a file. Again, this is used by analysis component. And then we have final. Everything is completed. If there is anything which is outstanding action by test bench, that also we will complete and end the simulation. Simple, very simple. What is the main purpose of cleanup? Things like knowing the pass fail status, doing the coverage analysis. That's why we need to extract information from scoreboard and coverage monitors. Four things we do: we first extract the information, then we check whether like test is pass or fail, what is the coverage. After extracting and checking, we will report whatever we have checked. And finally, if there is anything pending before completing the stimulation, any outstanding action, we will complete. Let's understand the steps to start the UVM phase execution. In order to start the UVM phase execution, you need to run test. Run test is a method. You need to run the test from the initial block inside your test bench top. Your test bench is going to have a top. In that top, there will be an initial block from which we will call run test method. What this run test method will do, it will check for UVM test case plus UVM test name plus args. UVM provides a plus args UVM test name where we will provide the name of the test, and then it will look up in the factory for the test which is registered with that test name. Then it will construct the UVM environment. After that, it will initiate the UVM phasing. Simple steps, we will call the run test from where? From the initial block in the test bench top. What it will do? This run test itself is going to do all these three things. First, whatever test name is provided in the plus args, it will look up for that in the factory. Then it will construct the UVM environment accordingly, and then it will initiate the phasing. These are the steps. Example I have given, say I have given plus UVM test name is the arg and name of my test is sweetie UVM test. Once you give this, we will look up in the factory for this test, and accordingly we will have the environment and initiate the phasing. Now let's understand this UVM phase flow. First we had build phase. In the build phase, we do the build using the UVM factory. Once build is done, then we need to connect whatever we have built. All the components need to connect in order to communicate to each other. Once we have connected, then we need to finish the elaboration so that we can move on to the simulation. So if any final configuration you need to do, you can do here. Remember it like in the build we do construct, then we do connect, then we do configure. Remember it as 3 C's: construct, connect, configure. After the build phase, we have the run phase. Until build phase is not completed, we can't move to run phase. This will complete in sequence. First build will happen, then connect, then end of lab, then the run phases will start. In the run phases, we first had start of simulation, where you can display some configuration or topology information. Then after that, your run and other four things are going to run in parallel. What were four things? Reset, which will do anything related to reset. Then, if you want to configure some things, and then in the main, we actually have the stimulus for the DUT, and then shutdown if there are any final actions by the TB before moving to the cleanup. We do that. In run, there will be start of simulation. After start of simulation, two things will run in parallel. One is this run and another is this sequence. Reset, configure, main and shutdown. This is how I represent it. Start of simulation, then it will go here. Run is happening in parallel and then this is happening in sequence along with the run. Here, when this run and this sequence started, it will be simulation start. When it completed, simulation end. It's not necessary that your run and this will complete at the same time. Whatever completes last, that will be your simulation end. But these both are starting together. So simulation start is same. Run and reset is going to start together. And whenever both of them end, it will be simulation end. Here your simulation started, here your simulation ended. Then we have cleanup phases. In the cleanup, we will first extract the information from your scoreboard and coverage monitors. Then we will check what happened, whether the test was pass or fail, what is the coverage. Then we will report whatever we have checked. And then finally, if there is anything left, you do that and finish. Do the cleanup. That's it. This is the UVM phase flow. Simple to understand with the help of this diagram. Build, in which there were three C's: construct, connect, configure. After build, we will go to run, in which start of simulation is happening. After that, two things will happen in parallel. One is run and another is the sequence: reset, configure, main, shutdown. Whenever this run and this sequence is starting, this starts together, which is simulation start. And whenever both of them end, which is not necessary together, then the simulation will end. Later on, we move to the cleanup phases, in which again there are four steps. First, we will extract the information, then we will check, then report, and then final. Let's summarize now. First is, we saw each of the test bench component is going to have your UVM phases, which are predefined. There were three phases. One was build, in which first build will happen, then connect, then end of a lab. In the run, first start of sim will happen, then two things will happen in parallel: run, and along with run, these will happen in parallel actually. Reset, config, main, shutdown will happen in parallel with the run. And then we have the cleanup, in which extract, check, report and final will happen. That's it about the UVM phases. I hope this information was easy to understand. You can go through this lecture a couple of times and, frankly speaking, with the help of those diagrams, try to understand. Try to create those diagrams which I showed you now by yourself. That will help you recall it easier. With the help of diagrams, it becomes very easy. If you are interested in learning such in-depth concepts, especially in VLSI, please stay tuned to Sweetie Speaks official YouTube channel by Sweetie Pinjani. I, Sweetie Pinjani, will see you in the upcoming lectures. Thank you.